FORA.tv. The world is thinking.
Let's shift back to the 19th century for just a moment, when the brain was still a gray slate. Now, I'd like to compare this image to the one right next to it, and they're separated only by 50 years. And yet they straddle a revolution that occurred in the mid-19th century that separates anatomical work after this period from all prior studies. On the right, this is a drawing by Camillo Golgi, 1875, and on the left, Sir Charles Bell, 1823. And the difference between these two images is on the left, you see sort of the gross outer contour of the brain, whereas on the right, we start seeing a representation of objects residing inside of brain matter. Something changed. What fueled this change, what gave ultimately birth to our modern concept of the neuron, is a miraculous convergence in the mid-19th century of two things. One, a new set of staining methods to mark nervous tissue. And on the other hand, new optical methods for actually being able to detect the fine structures that those staining methods reveal. And I say this as miraculous because if one had occurred without the other, they would have been fairly useless to neuroscience on their own. And so based on these two techniques, and I'll come back to the staining method in a moment, things started really appearing with great detail. Suddenly, inside that gray amorphous slate, there was a smaller element constitutive of the whole, and I like to liken this to the discovery of atom within matter. Let's pause for a moment here just to observe the exquisite intricacy of this drawing, by the way, by Camillo Golgi, who was the inventor of the staining method. A friend of mine very recently suggested that we should go into a business together and make fabrics out of this stuff. And in fact, it got picked up, I think, on a blog, on a fashion blog recently with just that in mind. So Camillo Golgi drew these exquisite representations of what he saw in the microscope, and yet, for the most part, was totally wrong, completely misinterpreted what he saw. He hadn't fully atomized the brain. He hadn't fully given us the neuron. And the man who dealt the death blow was Santiago Ramon y Cajal, a Spanish neuroscientist. This is him in a slightly more poetic disposition, and I'd like to draw your attention to his lab coat, which I like to liken to an artist's smock. And I think this is very significant, because Cajal, as a young man, was very interested, in fact, yearned to be an artist, wanted to be a painter and a drawer, and in fact, there are some surviving artifacts of his time as a sort of budding artist. And his father, against his wishes, sort of pushed him into medicine, and the rest is history. He created modern neuroscience, but never lost his eye for detail or his ability to represent very complicated things using very economical line. Now, I say he created modern neuroscience, but he must share the credit, and in fact did during the 1906 Nobel Prize ceremonies with Camillo Golgi. And this is because Golgi, whose drawing I showed just a moment ago, developed this terrific staining method that really clears the forest in the brain and allows the microscopist to focus on a few trees. So here's how it works. You have all this brain color. This is a piece of tissue where all of the neurons in it have been made dark, hypothetically. And what the Golgi stain does is it basically clears everything away and reveals small, distinct parts. It's still a mess to the rest of us mortals, to be sure, but Cajal was able to make sense of this mess. He had this incredible capacity for abstraction and generalization. And the process that he used to work, I think, is very informative. He would observe in the morning in the microscope, and then from memory in the afternoon would draw what he had seen. And so out of a sample like this one, where only about 1 to 3% of neurons are actually marked, and all the other ones are made effectively invisible, which is why you can start seeing shapes, out of a sample like this one, Cajal was able to see this. And this is really the modern neuron. This is how we think of neurons today.